equations by substitution. On Monday, we looked at 2 variable systems, and yesterday we looked at 3 variable systems, but we solved them both using the same method of substitution. What we are going to look at today and tomorrow is a new method. There's a typo here. I know it says substitution, so we need to mark that off in the title, mark off substitution up here. We've already talked about substitution the past 2 days. Now we're going to talk about an alternate method called elimination. Okay, that didn't get edited in the title before we printed these. My apologies. Okay, so we're going back to 2 variables for today. So just 2 equations, 2 variables. And we'll go back to 3 variables tomorrow. But we're going to start with 2 variable equations to introduce the elimination process. Okay, so yesterday we talked about, or actually Monday, when in this section for the substitution notes, we said, what is it? We talked about what our solution represented. We said that the solution represented the point where the lines intersect. Okay, it's the coordinates, x, y, of where these 2 lines intersect. That's what we're finding. Okay, that's what the x and the y value that we were finding in that substitution process represented. Okay, it represents the same thing still, but now what it is we're going to talk about what the elimination process is versus the substitution process. So elimination is, what we are doing is we are aligning equations to cancel or eliminate one of the variables Now, when we say aligning the equations, I mean, we're going to put them in the same format. So they're either both going to be in standard form or they're both going to be in slope-intercept form. It doesn't matter what form they're in. We're just going to align all the pieces. We're going to line them up. Okay, so you can see in step 1 here, it says, make sure the equations are lined up. Okay, when we get to an example, I'll make sure you understand what I mean when I say lined up. Okay, once we have them aligned, then to be able to cancel or eliminate one of the variables, we are going to add or subtract, depending what's needed. It'll vary depending on what the numbers are. Okay, but we're going to add or subtract the equations to eliminate one of the variables. Okay, it's going to be the variable with the common coefficients. What's a coefficient again? Yeah, the number right up in front of the variable. Okay, so if I have like 5x, 5 is the coefficient. So we're going to try to align the equations and we're going to look at the 2 variables. We're going to look at the x's and we're going to look at the y's and we're going to see which ones have common coefficients. That's going to be the ones that we eliminate. Okay, if they don't have common coefficients, we'll talk about how to get them to where they have common coefficients. Okay, and then once we do that addition or subtraction and we eliminate that set of variables, we're going to be left with only one variable and we're going to be able to solve for that remaining variable. Okay, now once we solve for one of the variables, once we get x equals a number or y equals a number, whichever it is, now we can go back and we can substitute your answer back into the original equation. Okay, and we can substitute or plug it in to either of the original equations. It doesn't matter which one. Sometimes when we look at them, one looks like it would be easier than the other, so you get to pick whatever one you want. Okay, so once we substitute that value back in, then we will solve for the other variable. So the last step, substitute, solve, that should sound familiar. Those were the steps in the substitution method. we went substitute, solve, substitute, solve. Y'all remember that? So now we're going to eliminate first and solve, then substitute, solve. Okay, so we're just changing up the first step of how we solve for the first variable. Okay, so looking at these two examples, both of these already have step one done. They are aligned. Okay, so when I look at these two equations in number one, they're both in slope-intercept form. I've got my y's, and then my equals, and then my x, and then my constant. So nice and pretty, it's aligned, good to go. So now I'm ready for step two, which is to add or subtract the equations to eliminate one of the variables with the common coefficient. Now that's if there is a common coefficient. Do the x's or y's here, do either one of those have the same coefficient? The y's, they both have an understood 1 coefficient. So these are aligned and the y's have the same coefficient. So this is set up really nicely for elimination. Now, they are not, they are the same sign, which means I can't add them. If I were to add those together, it wouldn't eliminate, it would give me 2y. So what do I need to do to eliminate the y's? So if I were to subtract y minus y, the y's would be gone. That's what we mean when we say eliminate. Okay, so some people will show it like this. They'll draw the line because we're going to subtract. It's set up like a subtraction problem here, but we're going to subtract each of those. Now, what gets tricky is it's the entire equation that is getting subtracted, not just the y. So everything, the y, the x, the constant, that negative has to go to all of those. So for some people, they can visualize it right here and do the math. Okay, for some of you, it would be better to go ahead and just rewrite it. Okay, so if I were to distribute that negative, this would become negative y equals negative x plus 2. And just go ahead and rewrite it with the distribution done. Now the top equation did not change. We didn't touch the top equation, so it stays as is. Now we can add. Now that we've distributed that negative, we can just add each of these terms, each of these columns, if you will. So what's going to happen with the y's is they're going to eliminate. Now, if there was anything else on the left side of the equation with it, we wouldn't have to write anything. But since that's the only thing on the left, I am going to write a 0, just to show there's a 0 over there. Okay, what are the x's going to combine to? 2x. Hang on, I've been having issues with my pen here. Stopped working. Let me close and reopen, see if it'll work again. You mess with the battery, see if it's a battery issue. Okay, but yeah, so the x's are going to combine to 2x. What are the constants going to combine to? Positive 6. So this is going to be 2x plus 6 on the right side of this new equation. Okay, so 0 equals, there we go, 2x plus 6. All right, so step 1 was get them aligned. Step 2 was to add or subtract them together. We've done that. Now, the second part of step 2 is to solve. Now that I eliminated the y, I need to solve for the x. So to solve for x here, I will move the constant by subtraction. That's the opposite operation for plus 6 is to minus 6. So I'm going to end up with negative 6 equals 2x. And I will divide out the coefficient of 2. And that leaves me with negative 3 is x. Okay, so now step 3, I'm finished step 2. I eliminated the one with the common coefficients and I solved. So now I need to go back and substitute that in and solve for the other variable. Okay, so I can take that -3 and I'm going to substitute it back in for x in either of these original equations. Now you get to pick. I think the second one is the simpler equation because there's no coefficient in front of the x either. So I am going to use the second equation, y equals x minus 2, and I'm going to make the substitution there. I'm substituting for x this -3. So then that gives me y equals -5. Now we talked about getting the x and getting the y separately. What do those numbers represent? And we're talking about a system of equations. And yeah, that's a coordinate of where, if I were to have graphed these two lines, this is the x and y value of the point where they would intersect. So we write our solution as a coordinate. So x, y. So -3, -5. You all okay about that one? All right, and number 2, they are nicely aligned again. This time they're in standard form. You've got your x term, and then your y term equals, and then your constant. Okay, so they are aligned nicely. Do either of the variables have the same coefficient? Okay, so the x's. So again, one of them already has the same coefficient. Same issue though here, they're opposite signs, or they're the same sign. We need them to be the opposite sign. So we're gonna have to multiply one of these equations by a negative. It does not matter which one you change. So do y'all wanna change the top or the bottom one? Bottom, okay. So we are going to take a negative and distribute it to that bottom equation. Okay, so that is going to become -3x plus 9y equals -15, because I have to distribute the negative because I need it to be the opposite. Now I'm just going to rewrite the original top equation just as it is. It does not matter which one goes on top or which one goes on bottom. Okay, it's just where I had the room to write it. Okay, so now when I combine like terms here, what's going to happen to my x's? They're going to cancel. That's the whole point. This is called elimination. We want them to eliminate. So then 9 and -10 is going to be -y. -15 and 14 is going to be -1. So what will y equal? -y equals -1. So what would positive y equal? +1. If you can't visualize that or see that, you can show the process of getting rid of the negative. That is actually just dividing by a -1. Okay, some of y'all will see it without having to show dividing by -1. Fantastic. If you need to show that step, that's okay too, because that eliminates the negative and leaves me with just the y, and a -1 divided by -1 is +1. So I've got my y value. Okay, so one of my variables is solved for. So now I'm going to take it and I'm going to plug it back in to one of the original equations. It does not matter which original equation we use. Which one do y'all want to use? Top one? Okay, so I'm going to take the top equation and I'm going to make my substitution for y. So that is a 1. I'm substituting here a 1 for the y. And now I'm going to solve for x. So I have to add the 10 to the other side. I get 24, and then I have to divide the 3 over. And I get 8. So now I've got X and Y. Remember that represents a coordinate. So this is the point 8, 1. That is where the lines would intersect if they were graphed. You could graph these by hand if you had graph paper and you wanted to check it. If you have access to Desmos, which you should, you could check it that way. You could plug these in, look at the graph, and go click on the intersecting point and see if it's 8, 1. Again, I said this the last 2 days. I'll say it again. Yes, you can use Desmos to do this. Please use it responsibly. Practice the algebraic steps and then use Desmos to check your answers. Okay, do not just do it in Desmos because then you're not actually practicing or learning the algebra. Okay, this is an algebra class. Okay, we're going to test that you know the algebraic steps. So you may have questions where we're like, what would come after this step? Or maybe we'll have one worked out. We'll say, where's the mistake made? Or things like that where the calculator Desmos can't tell you that. It's just telling you the final answer. Okay, and you need to know the process. Or maybe we'll have a pop quiz or something and you won't get Desmos. You have to show me the algebraic work. Okay, so that's what you need to make sure you're practicing is the algebra. Okay, now that being said, this process, elimination, versus the past 2 days process, substitution, they get you the same answer. So whether you're doing the substitution method or the elimination method, both of those are doing the algebraic work. I would like you to practice both on the separate assignments, but when we do have a quiz or a test, you can pick which process you prefer. Okay? If you want to use substitution every single time, great. If you want to use elimination every single time, great. I don't use the same one every time. I look at how the equations are given to me, how they're set up, and which one makes more sense or looks like it would be easier to do for that particular problem. Okay, so I use both. I don't have a preference one over the other unless it's the way that the equation is set up. That's what makes me prefer one for that specific problem. All right, so if we flip over to the back, what is different about this one than those others? It is lined up. I know what you mean though. The X's are lined up, the Y's are lined up, the constants lined up, but neither of the variables have the same coefficient. So it's not ready to just distribute a negative and eliminate. Okay, so when this is the case, just like we distributed a negative, okay, so go back and look at that. Distributing a negative, isn't that just multiplying by -1? You can multiply by any number that you want to, not just a -1, okay? As long as you do the entire equation, as long as what you're doing to one side, you're doing to the other to keep it balanced. So I can multiply either of these equations by any number that I want to so that it will eliminate one of the variables. Okay, so for instance, if I wanted to eliminate the X's, how could I turn a 2 into a -10? What would I multiply by? I could multiply this by -5 and it would become -10, which would eliminate the X's. Do y'all agree? Or look at the Y's. What if I wanted to eliminate the Y's? What could I multiply this 1 by to get it to a -3? By -3. So either way, I would be multiplying the bottom equation by something. Do y'all want to eliminate the X's or the Y's? The Y's. So that's a smaller number we're having to deal with. So that's fine. If we distribute a -3 to all of these, the Y's will be set up for elimination. Okay, so again, I'll write it off to the side here. So that's going to become, if I distribute this -3 to all three terms here, that will be -6x, -3y equals -24. I don't touch the top equation. I'm going to write it just as it was. So it stays 10x plus 3y equals 4. Okay, so now when I combine those, the x's, 10 and -6, would be +4x. The 3y's are going to eliminate because we have a positive 3 and a negative 3. Okay, and then I've got 4 and negative 24, so that's going to be negative 20. So I'm going to go to solve this for x by dividing out the 4. And I get x is negative 5. Okay, so I used elimination to solve for x. Now I am going to take that x value and substitute it back in to one of the original equations. Which original equation do y'all think would be easier for me to plug that into? You can do either one. The second equation has smaller coefficients to deal with, so that might make it easier for you. Okay, so I'm going to use the second equation. So I'm going to use 2x plus y equals 8, and I'm going to substitute negative 5 in for x. Okay, so that's the substitution I made. So that becomes negative 10 plus y equals 8. Then I would add that 10 over, excuse me. Okay, so I've got my x, I've got my y, so the coordinate would be negative 5, 18. And you can always check in Desmos with the graph, or you can check by plugging that x and y back into the equation, and it should make the equation true. It should make for both. It has to make both true for it to be a solution to the system. Y'all feel okay about that process? So this is, again, elimination. So there's a practice assignment for you in Delta Math. I'm going to pull it up here and look at it with you. When you go, let me get a student page, what it looks like for y'all. Oh, nope. Just kidding. JK, I got to activate it for you. Oh, what time is it? 9:29. Okay, so now you should see it if you refresh. Period. All right, so what you should be seeing when you log into your Delta Math is this. Okay, there is one possible assignment that might be under the past due tab for everyone, and that's the assignment from Friday, because this was due last night for full credit. If you did not finish it, it will show up under past due, and it shows you can still get 75% credit through the 12th. So that's tomorrow. So if you have not finished this one and you want to go back and finish it, that's fine. Okay, if that shows up under the complete tab, that means you finished it, you're good to go. Okay, and then our 3 assignments from this week. We had Monday, Tuesday, now Wednesday. Okay, these, I know it seems like a lot. You're like, oh, we do something every day, but they're not long. Okay, this one yesterday was 6 questions. Or I'm sorry, the one on Monday was 6 questions, okay, 2 from each level. Okay, this one yesterday, it looks like it's 8 questions, but remember we talked about how they were grouped. Okay, 6, 7, and 8 are all the same system. Okay, it's just broken it down into pieces. So really, this assignment is 3 systems that you're solving. Okay, so it's just broken down into parts. Okay, it's not as long as it looks. And then today's, if you look at today, we're practicing elimination with 2 variable. Okay, the elimination process, there's level 1 and level 2. So you can see 3 and 2. So 5 problems of the practicing the elimination. And then the elimination strategy, I have you trying 3, but these should go real quick. These are multiple choice, and it's just asking what strategy you should be using. So should I be adding or subtracting these to eliminate the X or the Y? So those questions are just making sure you understand the strategy, okay? And then actually solving, there's 5 questions that you need to get right, okay? The due dates are listed over here. If you want to work in order of due date, if they don't show up here, if they're under the complete tab, you're good. But anything that shows up here means you have not finished it. Okay, so y'all can use your notes. You can have out your notes from earlier this week. You can work in your small groups and talk to each other, help each other. You can have Desmos open to check your work. And of course, ask me questions. Please ask me questions. Okay, that's why I give you all class time to work so you can get the help you need when you get stuck.